Hello everyone, this is a question of CSIR-NET and this question is based on an unbiased and consistent estimator of parameter. Now we are given that sequence of IID observations xi from normal distribution, where mean is 0 and variance sigma square. Here IID means identically independently distributed random variables. Now firstly, there are two terms coins, unbiased estimator and consistent estimator. A estimator T is said to be unbiased estimator for sigma if expectation of T equals to sigma, and secondly T is said to be consistent estimator for sigma if expectation of T tends to sigma and variance of T tends to 0 as n tends to infinity. Using these two definitions of estimators, we try to solve these options one by one. Firstly, I label them T1, T2, T3 and T4. Now come to first option. T1 equals to pi upon 2 into 1 upon n to summation I1 to n mod of xi. First of all, as pi by 2 equals to 1.57 approx. Approx is good here, and pi by 2 square root equivalents to 1.57 square root equivalents to 1.25, which further equals to 5 upon 4. Now this implies that T1 equals to 5 upon 4 into 1 upon n sigma I1 to n mod of xi is can also be written as 5 upon 4 1 into n I1 to n xi minus 0. Now this further implies that T1 equals to 5 upon 4. In statistics, these terms is well defined and known as mean deviation of distribution about mean. Actually here xi belongs to normal distribution 0, sigma square. This is known as expectation of xi, that is mean, and this is known as variance of xi. Now in a normal distribution, we have a well-defined result, that is mean deviation about mean equals to 4 upon 5 sigma. Now this implies that T1 equivalents to 5 upon 4 into 4 upon 5 sigma. This implies that T1 equivalents to sigma. Now we find firstly expectation of T1. This is equals to expectation of sigma. As we know that expectation of constant is constant, and variance of T1 equivalents to variance of sigma. As we know that variance of constant is 0. From this implies that T1 is unbiased estimator for sigma, and from this T1 is consistent estimator for sigma, because expectation of T1 equals to sigma and variance of T1 equals to 0 as n tends to infinity. Is already equals to 0, so as n tends to infinity is obvious. Now come to option B. Here T2 equals to 1 upon n, 1 to n. Here I will use some result regarding expectation and its square root of estimator. Here we notice that T2 is not unbiased estimator, not unbiased estimator for sigma, because expectation of T2 cannot be equals to sigma in general, because expectation, that is E, is not good with square root function. That's why T2 is not unbiased estimator of sigma. But as n tends to infinity, and by property of consistent estimator, T2 is only consistent estimator for sigma. Now come to option C, that is T3 equals to 1 minus n minus 1 summation I 1 to n xi minus x mean, sample mean. This is again in square root, so T3 not unbiased estimator, and T3 is very well result regarding consistent estimator for sigma. Similarly, T4 equals to 1 upon 2 pi x1 square and xn square square root. This is again in square root, so T4 not implies unbiased estimator, and P3 is not consistent estimator because expectation of T4 never tends to sigma as n tends to infinity. Now this from this explanation we can say that option A is correct, option B incorrect, option C incorrect, and option D incorrect.